projectile motion and free fall. The first thing you should do is go to YouTube and search feather penny moon. You'll see that in space, which means there's no air drag, all objects fall at the same rate. The gravitational acceleration was the same for both objects in this video taken on the moon. Again, it's very interesting. You should go to YouTube and search penny feather moon and watch that video. The path of a projectile is called its trajectory. It is parabolic if there's no air drag. The projectile spends half of its time going up and half of its time coming down. The horizontal speed of a projectile remains constant. The reason that this remains constant is that there is no force in the horizontal direction. If there's no force, there's no acceleration, and with no acceleration, speed remains the same. The vertical speed of a projectile changes at a rate of 10 meters per second each second. The Earth pulls down on all objects and accelerates them so that the velocity changes at negative 10 meters per second each second. I've thrown a projectile at t equals 0, and it takes 2 seconds to reach its peak. On the way down, if I catch it at the same horizontal location, or the same height, I should say, not the same horizontal location, the same height, I will catch it at exactly the same speed. So if you look at the diagram, the horizontal speed never changes. The vertical velocity starts out at 20, then goes to 10, then goes to 0, then goes to negative 10, then goes to negative 20. So when I combine in the Pythagorean theorem 2 and negative 20, it's the same as combining 2 and positive 20. You catch the projectile at the exact speed you throw it at, although the velocity would be considered in a different direction. Now I'd like to talk about horizontal launch versus drop. We demonstrated that in class. Path A represents a projectile that is simply dropped. Maybe it's a ball. And path B represents a ball tossed horizontally off of a cliff. Both will hit the ground simultaneously. This is because the Earth is pulling on both objects vertically with the same force. So since B travels farther to get to the ground, it has a greater speed at t equals 4 just before it hits the ground. The other question that people often get wrong has to do with the acceleration of objects in free fall. That means under the influence of gravity alone. If I launch a projectile at an angle, and let's say it goes through path A, B, C, D, and E, is there anywhere on that path where the acceleration is equal to 0 meters per second squared? And the answer is no. Everywhere on that path, the acceleration is 10 meters per second directed downward. Is there anywhere on the path that the velocity is minimum? Well, we have a velocity minimum for the projectile on the left at location C, be equal to the horizontal speed. And if we launch horizontally, we have a velocity minimum at F. Hope this helps.